Hi guys, welcome to our channel of Sciences and Mathematics. In this channel we discuss about the concepts and in theory and practice of physical and biological sciences, and also some aspect of mathematics generally. So for that case, today we are going to have a topic in chemistry by the name Nomenclature of Organic Compounds, and specifically we are going to discuss about a class of organic compounds that we call amides. So for that case, amides are a class of organic compounds which we shall look at in maybe section of just naming, and then in details we shall look at it as we go ahead. So for that case, thank you and welcome. So as we have said, we are going to discuss about a nomenclature of the amides. Amides are as well another class of organic compounds, which of course we shall have to look at specific rules which are used in naming them. So in that case, we shall start with indicating the functional group for this particular class of organic compounds. Of course, and this will assist us to know how these compounds are formed. And that one will give us a clue in the nomenclature of different examples that we are going to demonstrate. So that is a functional group for this particular class of organic compound. So this one we have R prime and R prime prime to indicate the two radical groups which have been joined by, which are joined to the nitrogen group. Of course, we talked about the first, second, or the primary, secondary, and tertiary substitution on that nitrogen group. But this is a general functional group. This is a general functional group for the amides. Basically, it's a general formula that is used for all the amides. So for this is a functional group that demonstrates the general formula for the amides. So in that case, we shall have to look at the format that is used in naming these organic compounds. And as we said, the name of each member of this group, of course, does not necessarily start with a particular format, but it can start with any radical attached to the nitrogen group, and thereafter it can be followed by the name of an organic acid with the oic, that is a suffix in acid, replaced by the word amide. So in that case, the suffix for this particular group of organic compounds is the amide. And then there was this statement that I had said that the name of this particular class of organic compounds starts with N radical. We have written a functional group for this class of organic compounds like this. R. This is R prime, which demonstrated that this is different from this, and which is different from this. Of course, we're going to see if in case there is another unique maybe condition that is going to be forwarded. In this case, we shall discuss about it. But the format for naming, as we have said, is that each member of the group, the name of each member of this particular group start with any radical that it's attached to the nitrogen group, which means the name can either start with this or this, and then it will be followed by the name of the organic acid with the oic replaced by the word amide. So where does the term organic acid comes from in this nomenclature of amides? So we'll have to mention here that the amides are formed, or they can be produced by the reaction of an organic acid with amides. So in that case, it will be essential for us to give this particular two concepts that we have said. So these are the amides we are discussing about. They are formed by the reaction of an organic acid with the amides. Let's try to look at the functional group for this particular class of organic compounds. As we said that there are specific class of organic compounds that we have discussed, like the alkenes, alkynes, which stand on their own. But as we have proceeded, we have found that some classes of organic compounds like amides are produced through the reaction of other class of organic compounds. One of the examples is amides, that is formed by the reaction of an organic acid and an amine. Let's try to give the functional groups of the two class of organic compounds so that we can be able to see specifically how this class of organic compound is produced. So this is a functional group for organic acids, and then the functional group for amides, as we said, or we have already discussed, is that one. And then we said that the resulting amides, the functional group, can be demonstrated using this. So let me try to push this one near here so that we can have NH. This is a radical that is at this point. This is another radical that is at this point. So maybe I can try to indicate it using this so that we can be able to see the picture. This is a radical R, and this is a radical R prime, differentiating the two. So still I can push this one behind so that we get enough space. So we have R, and this is a COH. So this is for organic acid. This is for amides. Let's try to look at a functional group for, of course, amides. So it will be the simpler one. We had given a general formula in the discussion of amines, so we shall give a simpler one for that, which is N, and then like that. So which means at these particular points are the radicals which are attached, which I can indicate still by using R. Now, since it is derived from this particular organic acid, I'll just indicate it to be R so that it's the same as this one. And then we can, for the radical one, I can indicate this one as R prime and then R prime prime. Okay. So that's a general formula for the amides that we had given. So from this statement, the reaction between this one and this one produces the amides. So if we try to see the configuration or the changing of orientation of this particular compound in order to form that, we will of course try to look at an example of how this one is formed. and then that one will give us a clue on how this reaction takes place. So for that case, we shall look at an example and then try to see how this particular compound is formed from the two class of organic compounds, that's carboxylic acids and amides, as we have said. So let's look at one example of a carboxylic acid which is reacting with an amine to form an amide. So we shall have acetic acid, this is acetic acid 1, 2, or it can be referred to as ethanoic acid. So this is acetic acid, it's an organic acid or ethanoic acid. Acetic or ethanoic acid. So this is an organic acid, we add an amine. So we shall have this amine CH2. So we say that this will be a second degree or just a secondary amine because the nitrogen contains a single hydrogen and then it has substitution for those two methyl groups. So the name of that particular amine will be called or be referred to as two substitution. So it is dimethyl amine, and then they will form this particular product, which we said is amide. So the carbonyl carbon will be at that point, and then we shall have attachment for the nitrogen and the two. This is basically 2, then it's methyl groups, so it is CH3, and the name of that compound will be known as dimethyl acetamide. Dimethyl acetamide. So dimethyl, this is acetic acid, aceta, in that space, acetamide. I'll just put something that to indicate that it's a continuation, but this is not part of the nomenclature. Just because of the space, I put that one, so it is dimethyl acetamide. Now, because we have given this particular organic acid 2 names, the name can as well be dimethyl ethamide. Ethamide, because it's ethanoic acid, so it is dimethyl ethanamide. So in this case, we are seeing that the name from the parent carboxylic acid, like this one, in our case that is acetic acid. In this particular name, the oic part of the acid, that is the suffix, is replaced with the name amide. Let's try to see whether that's the case for that case. This is for acetic acid. Of course, that condition applies where we have oic. So that is where we shall have the term, this one. So it is ethan. So that was going to be ethanamide. 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 So this section of the name from here, so it was ethanoic. Ethanoic acid. Just confusing this. Ethanoic acid. So this has been replaced by the term amide. So that is the format that is being used to name this particular class of organic compounds. And the naming starts from the carbonyl carbon which is this one. So in that case, if we have a radical that is a long chain apart from this particular ethyl group, or from the carboxylic acid, that is ethanoic acid, then that is where the numbering begins from. And in this case, as we note, which is a characteristic property from the amides, the alkyl substituents in amides start with the term N, or the letter N. So we shall look at one of the examples that use this particular set of rules that we have said, the last rule that we have said, that is for N. Let's name one of the examples of amides and try to see how its name is being derived. So we have this example of an organic compound. This is CH3, and then we have, this is a carbonyl carbon, and then we have CH3. So in this case, we can see that this is a double substitution for the methyl groups on the N, or the nitrogen. So we shall have the name dimethyl. And then still we can see that we have, from the organic acid, we say the parent name is derived from the organic acid. So that's acetic acid. So we write dimethyl aceta, or acet. And then we write the suffix amide. So it is dimethyl acetamide. And then for the prefix, as we have said, we indicate it with the substitution, which is NN hyphen dimethyl acetamide. So that is the procedure that we shall use for naming those group or category of compounds. So the name for that particular amide, that is how it is named. Now for amides, they do not have a different characteristic apart from the one that we have said, and then their formation that we have said is the reaction between an organic acid with amides. So in this case as well, we have cyclic amides, but the cyclic amides have a special name, and they are known as cyclic amides. Change that one so that we can have a clear definition. So cyclic amides are also referred to as lactams, or just a cyclic amide. A cyclic amide is also referred to as a lactam. So that term, maybe if we come across it, we shall remember. So in that case, for this particular topic, we shall have to end it there. So thank you very much for being with me in this lesson. So I request for those of us who have not subscribed to our channel, kindly go to YouTube, search Mathematics and Sciences, subscribe so that we can be sharing our content and having a discussion, so that we develop new skills and additional skills in problem solving in physical sciences, biological sciences, and mathematics. So for that case, bye for today. God bless you. Thank you.